All right. So again, keep in mind, right, this is like the last little bit of loose ends we're going to kind of tie up before we start preparing for our benchmark. Tomorrow will be our official first benchmark review day, and we will then do a review day again on Thursday, and then finally Friday we'll take the actual benchmark, okay? Wednesday and Thursday, tomorrow and the day after tomorrow, we'll be doing practice benchmarks, right, which are very good representations of what the actual benchmark is. So please, 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 I can't stress enough, if you want to do on the benchmark, if you work hard on Wednesday and Thursday on those practice benchmarks, and if you really examine those and make sure you understand the concepts that are presented in those, you should be absolutely fine for the benchmark. Okay, so don't fret that yes, the benchmark covers everything we've done up to this point. You'll get a good idea of what's going to be on there, and it's very doable if you take those two practice benchmarks that we take seriously. Okay, so let's get into what like I said, we're going to do today here, and it shouldn't be too long. Okay, of course I say that, and we'll see, but it shouldn't be too long. Okay, hopefully. So the first thing I want to kind of hit here, we're not going to actually do this explore, okay, but I do want to mention here, so side-side angle, right? Is there a side-side angle congruence theorem? Okay, long story short, the answer is no, all right? Same thing with angle side-side, all right? It's the same situation, just with the order reverse, right? There is no triangle congruence theorem that's side-side angle or angle side-side. Okay, so if you see that show up, you know that you're wrong, okay? And it's not just because it spells a bad word. It really does not prove congruence. That being said, though, if you end up with side-side angle or angle side-side and I'll turn the page here, if you end up with that in a right triangle, that is a triangle congruence. But we don't call it side-side angle or angle side-side. We call it hypotenuse leg, okay? So if you have the hypotenuse and leg of one right triangle congruent to the hypotenuse and leg of another right triangle, that is also, those triangles then must be congruent, okay? And that's said right here in this hypotenuse leg triangle congruence theorem. Okay, when you look at the picture, right, like we have in the past, if you look at what you've got here, you have two sides and then two angles congruent, or sorry, two sides and a pair of angles, okay, congruent there. So if we read that like we've had in the past, right, you see it's side, side, and then angle, so side, side, angle. You might be tempted to say that, okay, but that's not a viable description. You need to say hypotenuse leg, okay, hypotenuse leg congruent to hypotenuse leg in a right triangle. The triangles are congruent, okay, so please don't say side, side, angle, please don't say angle, side, side, okay, hypotenuse leg there, all right, in the situation. So let's take a look here at the bottom of page 296. We're not going to prove it, so don't worry about that. We're just going to skip down here to page 296. Okay, given this picture here, okay, and now everything's game, all right, so it doesn't necessarily have to be hypotenuse leg. Is there enough information to prove? So again, it doesn't necessarily have to be hypotenuse leg here. It doesn't say using hypotenuse leg, but you could use it if you wanted to. Is there enough information to prove that triangle VWX is congruent to YXW? Okay. So again, if you tune me out, you're like, Mr. Wade, going over homework is boring. All right, Mr. Wade, I don't know why you explain all that other stuff. You tune me out here. You want to tune back in now, okay? And at least try this problem out here. So page 296 at the bottom, number 3. Is there enough information to prove that triangle VWX is congruent to triangle YXW? Okay. Do we have enough information there? So what do we say? So, what do you say?
Say yeah.
Yeah. Okay. Why do you say yeah?
Because it's the hypotenuse leg.
Okay. So I do see, like, for example, VWX, that is a right triangle, right? It's got a right angle. And YXW also is a right triangle, so they are both right triangles. I see that we have VW, that leg, is congruent to YX, that leg. But where do you see how do you know the hypotenuses are the same?
Because they share the same.
Yeah, they're both WX. Both of them have a hypotenuse of WX, right? WVX has the hypotenuse, same hypotenuse as XYW, right? It's both XW. And so, yes, the triangles are congruent by hypotenuse leg. Yes.
Could also be angle side.
So we do have vertical angles, but be careful. they're vertical angles for not the triangles that we're talking about here, right? We were talking about triangle VWX. So VWX, that's this triangle. See what I'm saying? So you would be right, though. If we were trying to prove this triangle here, congruent to this triangle here, then yes, it would be angle, angle, side, you could say there. Yeah. And actually, that's the same. When I first looked at it, Jackson, I was like, oh, it could be more than one. I was like, wait a minute, it's not the same triangles we're talking about. So yeah, be careful there. It gets a little confusing when the triangles overlap there. You have a lot of different things going on at once. All right, so let's take a look at then using the hypotenuse leg congruence theorem. All right, so in other words, we're going to do a few more triangle proofs. We're not done with those yet, right? So looking here, we have an easy example that's already given to us. Angle P and angle R are right angles. PS, we're told, is congruent to QR. And so then we want to prove the triangles are congruent. Okay, we can see then we have a reflexive side pair right there. And so we'll go ahead and say SQ is congruent to SQ by reflexive property. And so we then have hypotenuse, PSQ, and legs are congruent. And so it's right triangles. And so then we can use hypotenuse leg there. Okay, so pretty easy. All right, let's take a look at letter B. Okay, so letter B, given angle J and angle L are right angles, K is the midpoint of segment JL and MN. Prove triangle JKN is congruent to triangle LKM there. Okay, so very first step, we're told that angle L and angle J are right angles, and we know that's true because how do you know that angle J and angle L are right angles? It's because why? Given. Very good. Okay. Let's see here. Maddie G, how do we know that K is the midpoint of segment JL and segment MN? It is also given. Very good. Maddie G, since K is the midpoint of JL and MN, what can we mark congruent here in our picture? So you're saying that JL is the same length as segment MN? If K is in the middle of JL and K is in the middle of MN, they don't necessarily have to be the same length, right? For example, this MN could be like, I don't know, 6 units long, and so it would be like 3 and 3 here, and JL could be like 4 units long and be like 2 and 2 there. So like K could still be in the middle and not be the same length. But what segments could we mark congruent though? JK and KL, and what else? Yeah, there you go. And in fact, that's the next step there. Okay, and so we can say that's true. Emily, how do we know then that JK is congruent to LK and MK is congruent to NK?
Because K is the midpoint of JL and MN.
Yes, so you can say K is the midpoint of JL and MN. You can also just use definition of midpoint there if you want. That might be a little bit more abbreviated. Okay, and then with that information, we can say the two triangles are congruent because, what do you say, Chrissy? Hypotenuse leg, exactly right. Okay, did we have to use hypotenuse leg here? No. What else can we have more congruent here? So, Avery?
We could have marked the vertical angle, so we could have used angle side angle or angle.
Yeah, we could have used angle side angle. We could have used angle angle side. We could have used side angle side. Okay, so we had a lot of options there based on the given information and the diagram too. Of course, in the hypotenuse leg chapter, we're going to ask, they're going to want you to use hypotenuse leg and stuff like that. Okay. Well, that is annoying. They ask you to prove the triangles are congruent, and then there's like no space here for number 5. So let's do this one here maybe together. Well, we'll just talk it through maybe because there's not a lot of space there. Okay, so again, we have overlapping triangles. We want to be careful about what triangles we're trying to prove congruent. Triangle ABC, okay, so this big triangle here, and triangle BAD. Okay, so CAB and DBA are right angles, so we've got right triangles. We've got AD is congruent to BC, so AD and BC. Okay, what else can we say will be congruent in this diagram based on the way it's drawn? Or what's going to be congruent? What's going to be congruent between the two triangles there? Jackson? AB is shared by both. Okay, and so that AB is a leg for both of the triangles, and AD and BC are both hypotenuses, so we can prove it here by hypotenuse leg again. We can see that. Okay, so that's that. Questions on any of that? Okay, and that's all I've got. Okay, so wow, Mr. Witt actually held to his promise or what he said there, that that's what we were going to do, and that's all I really do want to do today. So with the remaining time, I would really like you guys to, one, finish up any of the constructions that you had to still do from your homework, okay? And then two, I'm going to give you a few problems from here to, give you some more practice with some proofs, of course, still, because proofs are going to potentially show up on our benchmark, okay? So, step one, finish up any of the constructions that you did not finish from last night's homework. Step two, I'll give you some assignment here. So on page 298, we'll say, starting on page 298, I'd like you to do numbers 1 through 5. Sorry, not 1 through 5, 2 through 5. Number 1. I'd like to have you try number 6 and 8. Those are both proofs there. And I think we'll be okay with that. I want you to try number 14 as well. Okay, and I think that's all I'll give to you there. Yes. Yes, you may. Okay. Yes. That's a good question. I'm thinking I might give you guys a break this week because of the benchmark and stuff like that. So, yeah, that's what I'm thinking. I know it's probably very disappointing to you, Chris. You're going to miss it, but yeah. All right. So Chrissy just asked, and she convinced me to not give you guys any 10 marks for this week since we have the benchmark. So that's what we'll do. All right. But don't worry, they'll come back with a vengeance next Monday. Maybe.